A special and a warm welcome to you, viewers. This is another edition where we're looking at grade 10 Euclidean geometry focused on the midpoint theorem. To help me explain the midpoint theorem, I'm going to state the theorem in full and make use of a diagram to explain the theorem in detail. So what does the theorem state? The theorem states that the line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. So what do we know in a nutshell? In a nutshell, we're saying that if we're having two midpoints, if the point D and the point E are midpoints of their respective sides, it follows that the line AD has to be equal to the line DB. And also, the line AE also has to be equal to the line EC. What other conclusion can we make? It follows that the line DE, that line DE has to be parallel to the line BC. And also, we know that the line DE, which is that line over there, has to be half in length of that line BC. So that's what the theorem states in detail. But to explain it and to formalize my explanation, I'm going to start by stating that the midpoint theorem is summarized as midpoint theorem. That's how you summarize the whole theorem. But my first statement, in order for me to explain that theorem in detail, I'm going to say that the side AD is equal to DB. And the reason for that, as you can see from the diagram, that's a given, it's marked. And also the side AE is equal to EC. Again, that's another given. You can see that from the diagram as well. We then make a conclusion that the side DE has to be parallel to BC. And the reason for that is the midpoint theorem. It is the midpoint theorem, and I've marked them on the diagram to see that those two sides are parallel. Also, we know that BC is actually 2 times DE. So I can say BC is also 2 times DE. Again, the same reason is the midpoint theorem in full. We move on to the converse of that theorem. So when I look at the converse of the midpoint theorem, again, I'm going to make use of a diagram. And if you look at the diagram, it looks somewhat similar. But the difference with this diagram and the previous one is that with this diagram, which deals with the converse, we are already told that the line DE is parallel to the side BC, which we are not given previously for the midpoint theorem. That would form our conclusion. Now that is a given. What we are not given, however, is that this side here, the side AE, is equal to the side EC. That is not a given. That's what we want to conclude in the end. So I'm going to take off all that so that I just go back to the original diagram. Then obviously I need to state the theorem in words, just like what we did previously. So the converse of the midpoint theorem states that a line drawn parallel to a side from one side's midpoint to the other side bisects the other side. A line drawn parallel to a side from one side's midpoint to the other side bisects the other side. So we're told here, to summarize it, that if there's a line that has been drawn from the midpoint, assuming that the point D is the midpoint, and is drawn parallel to the third side, then it follows that we are definitely bisecting the other side. So AE now has to be equal to EC as our conclusion. Similarly, I'm going to formalize all that and write it in words and say, what are we given? We're going to start with our given. We are given that D is the midpoint of AB. You can see that D is the midpoint of AB. What are we also given? we're given that DE is parallel to BC. From those two given statements, we can now say as conclusions, then the side AE is equal to the side EC. The reason for that is the midpoint theorem. And also, we can now make a conclusion that the side DE has to be equal to half of BC. The conclusion for that, we are dealing with the converse of the midpoint theorem. I hope you understood that. Until next time, signing out is Mr. T. Bye-bye.